Have you ever looked up at the night sky and felt a sense of awe? The vast expanse above us, dotted with countless stars, has a way of making us feel both insignificant and incredibly connected to something much larger than ourselves. The stars, like tiny diamonds scattered across a velvet canvas, have captivated humanity for millennia. Ancient civilizations used them to navigate the seas, to mark the passage of time, and to tell stories of gods and heroes. They have been a source of inspiration and wonder, a constant in our ever-changing world. They seem so still, so permanent. Yet, this apparent stillness is an illusion. The stars are in constant motion, just like everything else in the universe. They are born, they live, and they die, in a cosmic dance that spans billions of years. But the truth is, our universe is a place of constant motion. Galaxies rotate, stars orbit their galactic centers, and planets revolve around stars. This dynamic nature of the cosmos is what makes it so fascinating and mysterious. Earth, our home, is not at rest. It spins on its axis, giving us day and night, and it orbits the sun, bringing us the changing seasons. This motion is so smooth and consistent that we hardly notice it, but it is a crucial part of our existence. It spins on its axis and hurtles through space at incredible speeds. At the same time, our entire solar system is moving through the Milky Way galaxy, and the Milky Way itself is traveling through the universe. The scale and speed of these movements are almost beyond comprehension, yet the stars seem to hold their positions, night after night. How can this be? How can we be moving so rapidly and still see the stars in the same places in the sky? How can the stars appear so stationary while we are in such rapid motion? The answer lies in the vastness of space and the incredible distances between us and the stars. These distances are so great that the motion of the stars is imperceptible to the naked eye over short periods of time. The answer lies in the vastness of space and the incredible distances between us and the stars. Even though everything in the universe is moving, the stars are so far away that their relative positions seem fixed from our perspective on Earth. This essay will unravel this astronomical puzzle and explore the fascinating interplay between Earth's movement and our perception of the cosmos. Join us as we delve into the mysteries of the universe and discover the wonders that lie beyond our world. Our planet is always on the move. It spins like a top, completing one rotation every 24 hours. This rotation is what gives us day and night. But Earth's movement doesn't stop there. Earth also orbits the Sun, our local star. This orbit is a journey of 584 million miles, completed at an average speed of 67,000 miles per hour. To put that into perspective, that's about 18.5 miles every second. Given these incredible speeds, it's fascinating to think about the vastness of space and how it affects our perception of motion. Why do the stars appear motionless to us, even though they are moving at unimaginable velocities? The answer lies in the vast distances between us and these celestial objects. The sheer scale of space is almost beyond human comprehension. Stars are not tiny points of light hanging in the sky. They are massive, luminous spheres of plasma held together by gravity. They are giant balls of burning gas, much like our Sun, which is a relatively average-sized star in the grand scheme of the universe. But these stars are located incredibly far away from us, often light-years away. A light-year is the distance light travels in 1 year, about 5.88 trillion miles. Imagine standing in a vast field that stretches as far as the eye can see. The horizon seems endless, much like the expanse of space. Close your eyes for a moment, then open them. In the distance you might see a tiny speck moving across the sky. That tiny speck is a distant airplane. To your eyes it seems to move slowly, almost imperceptibly. It seems to move slowly across your vision, even though you know it's traveling at hundreds of miles per hour, cutting through the sky with great speed. The airplane's movement appears slow because of the vast distance between you and the plane. The greater the distance, the slower the movement appears. Now imagine a tiny ant crawling on the ground a few feet in front of you. Its movement is much more noticeable because it's so close. You can easily track the ant's progress as it moves across the ground. Its proximity makes its motion clear and distinct. This is similar to how we perceive the stars. The stars are like the distant airplane, far away and seemingly motionless. Even though they are moving at great speeds, their vast distance from us makes their movement seem negligible. The stars are constantly in motion, orbiting the center of their galaxies, and some even moving towards or away from us. But because they are so far away, their movement is imperceptible to the naked eye. This vast distance creates the illusion of a static night sky, a serene and unchanging canvas of twinkling lights. To truly grasp the concept of stellar distances, it's helpful to use analogies. Imagine shrinking our sun, a star with a diameter of about 865,000 miles, down to the size of a basketball. On this scale, Earth would be a tiny dot, about the size of the ballpoint in a pen, orbiting the basketball sun from a distance of about 25 feet. Now, consider the nearest star to our sun, Proxima Centauri. On this scale, Proxima Centauri would be another basketball located, wait for it, over 4,000 miles away. That's roughly the distance between New York and London. Section 5. A tiny shift. Parallax and the stars. While the stars appear fixed in their positions, there is a subtle shift that occurs over time. This shift is so minute that it is almost imperceptible to the naked eye, but it is there, and it has fascinated astronomers for centuries. This shift is called parallax. Parallax is a fundamental concept in astronomy that helps us measure the distances to nearby stars. It is the apparent displacement or difference in the apparent position of an object viewed along two different lines of sight. Imagine holding your thumb out at arm's length and closing one eye, then the other. You will notice that your thumb seems to jump back and forth against the background. This simple demonstration is a perfect analogy for understanding parallax. Your thumb seems to jump back and forth against the background. This is because each eye views your thumb from a slightly different angle, creating the illusion of movement. This is parallax in action, and it is the same principle that astronomers use to measure the distances to stars. This is parallax in action. By measuring the angle of this apparent shift, astronomers can calculate the distance to the star. The larger the parallax shift, the closer the star is to Earth. Similarly, as Earth orbits the Sun, our viewpoint of the stars changes slightly. This change in perspective causes a tiny shift in the apparent positions of nearby stars relative to more distant ones. This shift is what we call stellar parallax. This change in perspective causes a tiny shift in the apparent positions of nearby stars relative to more distant ones. The effect is more pronounced for stars that are closer to us, while distant stars appear almost stationary. However, due to the immense distances involved, this parallax shift is extremely small, even for the closest stars. The shift is so tiny that it is measured in arcseconds, which are fractions of a degree. To put it in perspective, 1 arcsecond is 1/3600th of a degree. It's like trying to measure the width of a human hair from a mile away. Despite the challenges, the measurement of stellar parallax has been one of the most important tools in the field of astronomy, allowing us to map the universe and understand our place within it. Section 6. The Cosmic Ballet, Stars in Motion. While the stars may seem eternally fixed in their constellations, they are, in fact, in constant motion. Like dancers in a grand cosmic ballet, stars orbit the centers of their galaxies, influenced by the gravitational pull of other stars and celestial objects. These stellar movements are often too slow to be detected by the human eye over a single lifetime. However, over thousands of years, the constellations we see today will gradually shift and change their shapes as stars continue their celestial dance across the cosmos. Section 7. Time and the Stars. A glimpse into the past. When we look at the stars, we are not seeing them as they are right now. We are seeing them as they were when the light left them. Light travels at an incredible speed, but the universe is so vast that it takes time for light from distant stars to reach us. For example, the light from Proxima Centauri, the closest star to our Sun, takes over 4 years to reach Earth. This means that when we look at Proxima Centauri, we are actually seeing it as it was over 4 years ago. Section 8. Our place in the cosmos. The illusion of stationary stars, while dispelled by scientific understanding, serves as a reminder of our place in the cosmos. We are passengers on a planet hurtling through space, surrounded by a universe far grander and more mysterious than we can fully comprehend. Yet, despite our cosmic insignificance, the human mind has been able to unravel these astronomical wonders, revealing the hidden movements and vast distances that govern our universe. Section 9. Conclusion. The everlasting wonder of the night sky. The next time you gaze upon a star-filled sky, Remember that you are witnessing a cosmic tapestry woven from vast distances, incredible speeds, and the illusion of stillness. The stars may seem eternally fixed, but they are engaged in a grand cosmic dance, their light carrying stories from the distant past. Let the wonder of the cosmos ignite your curiosity and inspire you to learn more about the universe we call home.